Hey, here we are. It's time for another episode of JP's Product Pick of the Week. You're right here, the right place at the right time. And I want to say thank you for everyone for stopping by over in the chats. We've got the YouTube chat. I'm looking at it right there. Hey, Dave and Tackle the World and Bill and Ethan. Nice to see you all. And if you're wondering where the chat is, if you're over on Twitch or some other place like that, and it doesn't seem like anyone's in the chat, that's probably because they're in our Discord. And if you want to jump in, that's the Discord. There's all kinds of kookiness going on there. You can just head on over to adafruit.it/Discord. You'll jump right into our Discord server, and you'll head over to the live broadcast chat channel. And that's where our other conversations are going on. Hello, Connor MacArthur. Nice to see you. Hey, Jim, Rich Sad, Todd Bott, Dexter, Cup of Coffee. Hello, and thanks for joining in. Jim Hendrickson. Howdy. So, without further ado, let's jump into it. If you want to check out the product pick, this is the URL for you. And that right there is the discount at the product page. So go to that QR code, jump right in. You will see this show happening right inside of there in a little window. You can just check that out right there if you want. And you have an instant discount applied to this week's product pick. No need for a coupon code. You can just throw it in your cart and buy it. Do it quick, because sometimes these things go fast. But before I say any more, I will have Lady Ada introduce this from the original product launch. So please take it away, Lady Ada.
FeatherWing. This is a little handheld demo. I have a little display over here, and this is just showing all the buttons being pressed and detected. There's a select button. There's up, down, left, right buttons, and then up, down, left, right analog joystick. And you can read the analog values. I'm just sort of detecting if it's pressed or not. But it's one of those thumbsticks, kind of similar to a PSP. It's kind of a knockoff PSP connector. Works just fine as a potentiometer. And you got 5 buttons. What's neat about this is one of the issues with feathers is it's actually kind of hard to find commonality of all the feathers. That allows you to have 2 analog pins and 5 digital I/O pins, because some, like the ESP8266, only have 1 analog input, and some have the analog outputs on the first 2 pins, and so maybe you don't want to overwrite those. And we were looking around for a chip that could do 2 analog inputs and also 5 digital inputs for like an I2C converter, and it didn't exist, so we made one. So this is our first Seesaw board. Can you go to the third image?
Yeah. What is Seesaw?
Seesaw, you can see our lovely logo underneath the Feather logo, is a chip core that Dean wrote. He's an engineer here at Adafruit. And what it does is it converts I2C to a variety of protocols. So instead of just having an I2C to analog converter, an I2C to temperature, I2C to digital I/O, you can configure the chip however you want, and then you program it, and then it kind of acts as like a universal translator from I2C on one side of the Seesaw to almost anything else you'd like on the other side. So this is our first Seesaw product. We're going to be using this a lot because there's a lot of situations where maybe you want a rotary encoder to I2C. Doesn't exist. There's no such thing that does I2C to rotary encoder, but it's very hard to make sure that you have a device with multiple rotary encoders. It's very challenging to have enough timers to manage them. There's a lot of code that is required. By having the Seesaw chip, which is a very low-cost ARM Cortex chip, do the management for you, we can basically have this like fully featured, Feather Joywing, and the chip costs as much as a normal I2C GPIO converter, but we get to customize it with whatever we want. So it's basically a 70-cent chip, same price as like an MCP 23008 or a PCA something, so whatever.
Keeps our pricing low, and you get all these extra things.
And it's more functional. You get more.
In the chat, congratulations to you and everyone who worked on this, because they're impressed.
Yeah, we're going to have more documentation. It is going to be open source. We have to release all the libraries for it, so you can make your own. It's based off the SAMD09, which is a very low cost. It's the lowest cost Cortex M0 you can get, and has a built-in crystal, and it has a DAC, ADCs, a lot of ADCs, a lot of digital IOs. It has DMA. It can do like neopixels. It can do timers. It's got very functional. And it's, the cheapest chip we could find that can do this. So you're going to see this logo a bunch, because there's a lot of times where we want to add like a feather that has a rotary encoder or UART or multiple analog ends, and we need something to convert to I2C, that's going to do it. And that means it's easy for you to stack multiple FeatherWings without having to worry about collisions. This is also why I did that gigantic I2C list like a month ago. I had that list of every single device with every I2C address that was used, because we wanted to make sure that we didn't collide with any popular I2C addresses.
It all makes sense now.
And you can also see on the bottom you can select multiple I2C addresses and more. So we'll be chatting about that soon, but right now you can sign up. We'll get this in the store soon. And we have CircuitPython, Python, and Arduino libraries. Or maybe, yeah, we have all three right now.
Yeah.
So you can use this with anything, and works great.
Okay.
Yes, that's right. This is this week's product pick. What I'm going to do is go ahead and jump to the down shooter here and grab my own right here from the lovely little mystery box of goodies. And there that is. So let's talk about this right here. That's the product pick of the week this week. It is the Joy FeatherWing. Now, the Joy FeatherWing, you can see here it says, and Lamore mentioned that it's got 5 buttons and a joystick. So this is a PSP style analog joystick. So it's a potentiometer that goes from 0 to 1023, 0 to 1023 for X and Y axis. And it also has the 4 A, B, X, Y buttons, if you talk about it in sort of NES style naming. It also has a select button at the top. There is a 6th button. Someone mentioned that over in our chat. As I mentioned, why do I see 6 buttons? This 6th button is a reset button, and that's the same reset button as is on the Feather. So with that connected onto a Feather, you'll just be able to still reset the board even if this is hidden, if you put this right on top of a Feather. So the other cool thing is, yeah, this is the original Seesaw board. I had forgotten that, but this was really what kicked off this really great series of boards. We have lots and lots of cool boards out now that act as I2C to whatever, which makes it really convenient to string lots of them together, to plug them into almost any microcontroller that has I2C. Some of them plug right in, some of them you can use Stemma QT or Stemma formats for, but they all have that commonality of that little chip, that little Stemma, or rather that little Seesaw chip that is taking care of finding out what's going on the board, in this case collecting the analog inputs from the 2 potentiometers and that joystick and those 5 button presses, and then sending all that info over I2C. There's even ways we can do that are really nice and fast, really responsive, which I'll show you here in a second. So you may have noticed I'm wearing my Pip-Boy here today, and that's because this is the board that's on there. So if you see I'm moving my little cursor around there, that's using the Joy FeatherWing there on top of a Feather RP2040, and then I have this display here, and I can use these buttons here to change things. So that's a Joy FeatherWing right on top of the Feather. Here, if I jump to my overhead, I'll show you another example of the FeatherWing in action. So here's one where I have soldered in some header pins, and then I've taken a little Feather tripler. This is a really nice way to use this. You can build up a little modular device. I have a Feather here, a Feather M4, and then I'll plug in my Joy FeatherWing underneath. And then you'll see I also have another I2C device here, which is this OLED FeatherWing. But since they're on different addresses, we can use those together, no problem. And this one here, I'll plug this in. This is just a little demo. I'm using the OLED just as a simple REPL, a little readout of the serial that's going on. So I can do things like tell me what button I'm pressing, A, B, X, and Y. And this is the main demo code over in the Learn Guide for the FeatherWing. And then you can see as I move that joystick around, I get different readouts. I was actually noticing right before the show, I think I put these values backwards. So X is showing up in the second position there. So this is YX readout, oddly enough. So we could just change that in code to fix that. And same with the select button. So that'll show me that I've pressed select. Oh, that one's flying off the top there. If I press this bottom one, you'll see it's going to reset the whole device. So it'll restart, clear the display, and then we're back. So that's a nice use of it. Let's take a look. I mentioned the guides here. Oh, there's the Pip-Boy guide. So you can see there's the Joy FeatherWing off to the side. If we go to the main guide here, there's some nice photos of it there. If I refresh this, we should see this at half price right now. It's still in stock, maximum of 10 per customer. So for $5, $4.98, you can pick up one of these or up to 10 of them and build some cool projects. And if we scroll down here, you'll see some info about it and then some links to different Learn guides. There's one about Seesaw itself, which is pretty interesting. And then we have the Joy FeatherWing guide. And this will take you through the overview as well as the pinouts. And again, the nice thing here is that if you look at these overlays here, Kattni does these nice overlays, you'll see we only have the power and ground pins in use down here, and the data pins used here, and then I think the reset pin is also connected, but no other pins are used. So if your Feather has connections to other things, particularly if you're using a doubler or tripler, no problem. This is not using many pins. Compared to if you were gonna hook up 2 analog things and 5 buttons, you'd have a whole lot of GPIO taken up. So that's the nice thing about this Seesaw and its ability to collect up all that info and send it over I2C. You can also use an interrupt pin if you need to in your code. And what I wanted to do now is show you, whoops, 1 second, my interface is flying all over the place on me here. I wanted to show you another really cool demo, and that is something I just did, which was I ported Toddbot's most excellent asteroids game, which he already has running on a bunch of our CircuitPython boards that have a display on them, and including like PyBadge and Funhouse and things like that. And what I decided to do is make a little sort of game console using the FeatherWing, and you can see there it's just connected over I2C. So I've got the serial data, serial clock, power, and ground. And then those are running into the stemma, the 4-port stemma board on the side of the Pi portal. And my favorite feature of this is I can hit that little select button and it'll go to a different color scheme. And so now we have this really cool asteroids game here. It's even got some sound effects. They're not very loud because I'm just using the built-on speaker. You can see the NeoPixel light up there at the top. I can use the little thruster there. Whoa! And that's all. Let me get the board that I'm trying to show off here on screen. So you can see there I'm using my thumbstick there to rotate the little ship. And then I can use the B button to thrust, get away, and then I can do the old Death Blossom and fire off, I think, a maximum of 5 shots before it pauses and waits for one of those bullets to die. You also can't die in this version of asteroids, so it's endless. So really nice little mini version of a console there, but you can imagine that these can be incorporated into your projects, kind of like I did here on the Pip-Boy, build it into a case. One other thing I saw recently, this is really cool, is someone built a gizmo that looks a lot like a Nintendo Switch by mounting a FeatherWing on either side in 2 different orientations. So you get thumbstick at the bottom on this side and thumbstick at the top on that side, or vice versa, and it mimics that sort of layout of a Nintendo Switch, which is pretty cool for gaming stuff. So let's see, let me check out the chat and see if there's any questions. The boards are listed. If you have a question here, let me bring up the Discord. Someone had a question about which boards you'd use Seesaw, I think. So there's some linked there. I think all of our little Neo slider and Neo keyboards use a Seesaw. The Cricut robotics platform uses Seesaw, and there's that there. You can imagine just gathering up tons and tons of different I/O things and just sending them over that I2C. There's a really great picture of Rich's desk with a ton of projects going on. That's impressive. All right. And over on YouTube, East Power Engineering says hello from Kenya. Welcome. Thank you for stopping by today. All right, so back to the matter at hand, this Joy FeatherWing. Like I said, if you head to this URL right here, you can go and check it out at the store. You can pick them up there for half price right now. Just throw them in your cart. There's no discount code needed. And let's see if we got any other thoughts or questions before we wrap this up. Yeah, Rich said he has Cricuts and Neo sliders. It's a good question. Do we have a page called Seesaw that just lists them all? If not, that would be kind of cool. Probably also checking out our Seesaw GitHub repository would give you some clues on that. And what else is there to say? That's my Atari 26 joystick by Coop. Homage to that today. And let's see, am I missing anything else? I think that's going to do it. So let me go ahead and grab this one and prep it for hanging on the board there. Just going to put a zip tie through it. Impromptu hanger. The Joy FeatherWing does have mounting holes there that match the mounting holes on a Feather, so you can mount it directly on top, or same with our doublers and triplers. You'll see there's a set of mounting holes that allow you to mount that on there really nice and secure. All right, well, if there are no other questions, I think that's going to do it for today. That is my product pick of the week. It is the Joy FeatherWing. Thank you, everyone, for stopping by. This has been another episode of JP's Product Pick of the Week for Adafruit Industries. I'm John Park, and I will see you next time. Bye-bye, everyone. Hang on, I think I just missed something. I knew there was something I missed. If you're still here, great. And that's what I wanted to show was actually, let me jump back to my overhead in a code view. I didn't really show you how you read the joystick and buttons on this. So little backup here. Backing up a second here, I got ahead of myself. So I knew there was something I missed. Let's take a look at a view just like that. Okay, so for this example here, I'm gonna go ahead and open the code that I put on this board. This is basic demo code plus display. So this is the basic Joy FeatherWing code here, plus a little extra. Whoops, wrong one. I gotta unplug this one here. I have too many devices called Circuit Pi on my computer. All right. Okay, so you can see here, if I move the joystick around, I'm seeing different potentiometer values, 0 to 1023, so it's an analog read. And then I have the different buttons that I'm able to read. I'm going to go ahead and try to open that up on the serial output. So that's the same stuff that's being printed to the screen there. Okay, and so you can see here to use this, all I'm doing is, the main thing is importing Seesaw. So from Adafruit seesaw.seesaw, import Seesaw. And then I'm setting up this bit mask. So this is going to essentially read all of the buttons as one, or rather byte mask. It's going to read all those buttons and just send me a series of zeros and ones to say, is a button pressed or is it not pressed? And then I'm going to do an analog read for the joystick, and all of that comes over I2C when I read the board. So I've set this up on the I2C bus as a Seesaw object. You can see there pin mode bulk is set to read the button mask, and I have input pull-ups on those buttons. And then we're setting the display up a little bit here. So in the main read, all we do is send this call Seesaw analog read, and that gives me the X and the Y. And then if those are changing by just a little bit, then we display them. That's just to keep it from flooding the display all the time. And the button presses are all based on this checking to see the value of those, the byte mask there of zeros and ones if things are pressed or not pressed. And so if we have a 1, then that means that button is pressed. So button right will show up when I press button A, button down there, press button B, and so on. So it's really straightforward to read them. There are other ways to do it. This is one of the fastest ways to get all those buttons sent at once. But you can see here, this type of analog read is simply ss or seesaw.analog read, and that will give you the info. Now I said here, this looks like my values are transposed. So as I move left and right, that second number is changing. I actually want to fix that. So print x, y, yeah, so I just got to change which ones I'm reading here. So this should be analog 3 for x and analog 2, not 22 for y. I'll save that. And now you can see the first number there is going from roughly 0 to 1023, and then the bottom number is 0 at the top and 1023 at the bottom. All right. So that's how simple it is to code for the Joy FeatherWing inside of CircuitPython. You can also use it with Arduino for other types of projects. And bonus question, I just saw someone asked about, did I scale it? No, I think that is the range it gives. It may be a higher, Rich asked about the scale to 1023. I'm not sure if I said something else, but yeah, 0 to 1023 is the readout that you get when you ask for that analog read. It may be a higher accuracy or higher, deeper depth range for analog read on the board, but that's what we get back when we're querying it. Dexter asked, could this be used to make music? Yeah, in fact, I was thinking about doing, I had enough demos for this, but I was thinking about using it for a demo of just sending out some different waves at different frequencies. I had a piece of code running on these two before that was just using these buttons to change between frequencies and values, and I had an encoder or a potentiometer. But this would be a nice one for doing music stuff. You could use this as a pitch wheel and a mod wheel, or use it for an interface. Use these buttons to send things, send notes out to MIDI, that sort of thing. So yeah, for sure, this can be a really nice little interface for different types of music projects, along with loads and loads of others, robotics for little remote controls and that kind of thing. All right, so now we're actually done. Yeah, that's the epilogue. That was the epilogue. There was something bugging me. I was like, I can't have done everything yet, can I? All right. So that's it. Thanks everyone for stopping by today, and I will see you next time. Remember, we've got Show and Tell and Ask an Engineer tomorrow. I'll be back on Thursday with my workshop show, and we'll have deep dives with Tim and possibly Scott on Friday. So check the schedule for those, and check our blog posts and social media, and we'll let you know what's going on. Okay, that is it for real this time. There is no second encore.